This lesson is on half-angle identities for trigonometry. Before you do this lesson, you should have already learned the double angle identities for trig. We might review one of those here in a second to verify one of our new identities. I've encouraged you on these lessons that each time you have a new set of identities that you commit those to memory right away so that you have those to use and that you're not trying to learn all of your identities all at once. Let's take a look at how we can develop what we call a half-angle identity. To do this, I'm going to use a familiar double angle identity. Suppose that we take one of our double angle identities for the cosine. Cosine twice a. One of the forms that we learned in our previous lesson was that cosine 2a can be rewritten as 1 minus 2 times sine squared a. Now what I'm going to do here is to solve for the sine of a in this formula. So I think what I'm going to do first is let's subtract, well, I tell you what, I think I'll do this. Let's subtract, or add rather, this 2 sine squared a and bring it over here. And then we're going to subtract this and bring it over here. Can I do both of those on one step for you here? I'm adding the 2 sine squared a, and I'm subtracting the cosine of 2a. So that just moved this term over here and brought this one over here. And now we will divide both sides of this equation by 2, which gives us sine squared a equals 1 minus the cosine of 2 times a, all divided by 2. And then, of course, if I want to solve for sine a, I need to do what next? Take a square root, don't I? Of course, when I take a square root, I have to remember there is both a positive and a negative square root, and we would choose which one depending on which quadrant our angle A was in. Since we don't know what angle A is, what I'm going to do here in this formula is just to say I would have to decide whether to use a positive or negative square root here, depending on the quadrant for A. But having taken that square root, notice it's really the double angle identity, but in a different format here. The sine of angle A can be found by choosing either the positive or the negative square root of 1 subtract the cosine of twice whatever A is, all of this divided by 2. Now I want you to key in here on the relationship that exists between this here and this here. Now I usually refer to those as angles, but remember those could be numbers. If our angle is given in radian measure, for instance, that's considered just a real number. But what I want you to notice is whatever is here, if I multiply by 2, I get what's here, right? So in other words, if I had 15 degrees here, then I would have 30 degrees here. This is twice as much. Looking at that sort of going in a reverse direction, if I know what is here, and I know that that's twice A, what would I do to this to get just A here? I would divide by 2, wouldn't I? And so what I'm going to do is to rewrite this identity, and I'm going to put it in a slightly different format for you, but it's really going to say the same thing to you. Let's look at what I did. Instead of calling this A, I'm calling it A over 2. And instead of calling this twice A, I'm calling this A. Now remember, A is just a variable, so it's not necessarily the same thing here as it is here. But let's look. Notice that whatever I have here, if I multiply A over 2 times 2, I get A. Just like here, if I multiply A times 2, I get 2A. So I still have that relationship that whatever is here, if I multiply by 2 or double it, I get what's over here in the formula. Or in reverse, whatever is here, if I divide by 2 or take half of it, I get what's over here. This last form that I have for you right here is actually the form that we use when we write the half-angle identities. Now on this page I have for you the half-angle identities for the sine and the cosine. Now to develop this half-angle identity for the cosine of A over 2, I would do basically the same thing that I did in this last example using a double angle identity, but I would use the form that said cosine 2a equals 2 cosine squared a subtract 1, and then solve. I would get to here. So let's look again at these formulas. The sine of some angle divided by 2, or some number divided by 2, is either positive or negative square root 1 subtract cosine of, in this case, a, twice whatever was here, all divided by 2. The cosine of a over 2 is plus or minus the square root of 1 plus the cosine of a, again, twice what's over here, divided by 2. Now, the nice thing about these identities is that they're exactly alike except for the sign that you see right here. So you sort of learn these together, and then it's just a matter of remembering which one do you say 1 subtract and which one do you say 1 plus. Now, I always sometimes come up with little tricks on ways to remember things, something unusual or catchy, and I had a friend tell me one time a way to remember this that I've never forgotten. He said on these half-angle identities, if you'll just think sinus minus, you know, that's really silly, but I have never ever forgotten that. And it always helps me when I'm working with these half-angle identities to remember which one gets the subtract and which one gets the add. Now again, the emphasis is on the structure. Whatever you have over here, multiply by 2 and you have what's here, or whatever you have here, you divide by 2 and that's what's over here. Now, about this plus or minus thing, this plus or minus is the sign that we will choose. If we're calculating a sign, then the sign will be positive if we're in quadrants 1 or 2, and negative if we're in quadrants 3 or 4. Now, when we're talking about which quadrant we're in, which are we concerned about? Well, we're concerned about this a over 2. Whatever this number or angle is will determine which quadrant we're in and whether our sign should be positive or negative. Similarly here, whatever a over 2 is will determine our quadrant, and if we are in quadrants 1 or 4, we'll choose the plus sign, but if we're in quadrants 2 or 3, we'll choose the negative. Now, I would encourage you, spend some time again with these identities. Get these things memorized right away. We will be referring back to them here on this tape since this is maybe the first time you've seen these identities, but you need to commit them to memory. Now here we have the half-angle identities for the tangent function. And the bad news is there's 3 different forms of this identity. Remember, on the cosine of 2 theta, there was 3 different forms that we could use. So we have that same choice here. Let's look at these. The tangent of a over 2 is plus or minus the square root of 1 subtract the cosine of a, all divided by 1 plus the cosine of a. Now here, notice you're going to have to choose your sign depending on your quadrant for a over 2. If you're in quadrants 1 or 3, you'll be choosing the plus sign. Otherwise, you'll choose the negative. But again, notice the format. Whatever you have here, if you multiply by 2, you get what's over here. Or vice versa. Whatever you have here, if you divide by 2, you have what's here. Now, these other 2 forms of our identity for the tangent of a over 2 are nice in that we don't have to make a call as far as whether we use the plus sign or the minus sign. You'll notice on these formulas, we don't have to make that choice. By calculating these values, the sign will take care of itself. So one form of the tangent of a over 2 that we can use is sine of a divided by 1 plus cosine a. Again, notice the relationship. Whatever's here times 2 gives us what's here, or whatever is over here on this right-hand side, we divide by 2, we get over here. The other form, tangent a over 2, is 1 subtract cosine a, all divided by sine a. Now again, spend some time with these identities and commit them to memory. Actually, I can remember the first one a little bit easier than the other 2 sometimes because of the half-angle identities that I already know. Notice that I remember tangent is sine divided by cosine. If I take this and divide by this, notice how the 2's would cancel and I would end up with the 1 minus cosine over the 1 plus cosine, which is this form here. So again, whatever trick you might need to come up with to help you remember identities, you do need to work on those. Now we're going to go to some problems, and the first several problems are just going to be working on rewriting expressions using these half-angle identities. Well, let's look at this first one. We're to use an identity to write the following as a single trig function. Okay, well let's see. This is the square root 1 plus the cosine of 76 degrees all divided by 2. Now you'll notice in front of this it's positive. Okay, well we'll talk about that in a moment. What I want to do is to sort of slide these identities, if you can see these, along with that problem to compare. We've got the square root and we've got the 1. Notice the plus sign here in our problem. That would say what we need to use this second identity, don't we? And everything else is going to fit right into the format. So evidently we've chosen the plus sign. I think once we get over here you'll see what's happening. What I'm going to do is to write that identity down here. The cosine of a over 2 is plus or minus the square root 1 plus the cosine of a all divided by 2. Again, I encourage you as you do homework, write the identity down and sort of say it to yourself. Usually by the time you've finished your homework assignment, you pretty well know your identities. It really does help to do that. So we're going to fit into this formula. We have the plus sign and we have this sign. So in our problem, A is 76 degrees, isn't it? So what do I want to do to get over here? I want to take my A and divide by 2. Well, A divided by 2, let's see, that's going to be what, 38 degrees? Okay, so we know that this is equal to the cosine of 38 degrees. Now notice 38 degrees is in quadrant 1, and so in quadrant 1 we would choose the plus sign because our cosine is positive in quadrant 1. Use an identity to write the following as a single trig function. We have plus or minus the square root 1 minus cosine 3 theta over 5 all divided by 2. Now again, since perhaps these are new, let me slide this identity up here and let's look at it compared to this. Notice your 1 subtract cosine and you have all that over 2. So that's the identity for sine a over 2. Again, I'm going to write that for you. The sine of a over 2 is plus or minus the square root 1 minus the cosine of a all divided by 2. Sinus minus. Okay, in our problem we have this side over here. So a in our problem is 3 theta over 5. Now what do I need here? I need a divided by 2. Well, remember, a divided by 2 is the same thing as 1/2 times a, isn't it? Let's do it in that form. 1/2 times 3 theta over 5 is going to give me 3 theta over 10. So this is going to equal the sine of 3 theta over 10. Now you'll notice I can't decide yet about the plus or the minus because of this theta. I don't know which quadrant 3 theta over 10 would be in. Use an identity to write the following as a single trig function. Now here you'll notice I don't have a square root. I just have the sine of 158.2 degrees divided by 1 plus the cosine of 158.2 degrees. Now if you remember looking at those identities for the tangent function, let's look at those again. See here I have sine A over 1 plus cosine for tangent A over 2. That's the one that we're going to want to use. Do you see? Sine 1 plus cosine. So let's write that identity down so we can take a look at it. The tangent of A over 2 is the sine of A divided by 1 plus the cosine of A. And you can notice in our problem we do have the same angle here and here, like the A and the A. So in our problem, A is 158.2 degrees. Now what do we need over here? We need A divided by 2. So let's see, that's going to be 9.1, isn't it? Of course, you could do that with your calculator if you want to. Tangent 79.1 degrees would be our single trig function. Use an identity to write the following as a single trig function. Now notice here we have plus or minus the square root of 1 minus cosine 5a over 1 plus cosine 5a. Now let me slide this back up here. See our first form of our tangent a over 2, plus or minus 1 minus cosine, 1 plus cosine. So that's the identity that we'll be using. The tangent of a over 2 is plus or minus the square root of 1 minus the cosine of a divided by 1 plus the cosine of a. So in our problem, if we compare, what we have instead of a is 5a, right? And so over here we're going to get tangent, and we want to take what we have here, that 5a, and divide by 2. So we have the tangent of 5a over 2. Now I hope just from these problems that you're beginning to get the idea of the relationship that exists from one side of these half-angle identity problems to the other. If you have tangent a over 2, multiply that by 2 to get what's on the other side, or if you're going in the opposite direction, you divide whatever you have over there by 2. Now let's look at some other types of problems where we can use these half-angle identities. This one says to use a half-angle identity to find the exact value of the tangent of 15 degrees. Of course, 15 degrees is not one of our special angles, is it? So I'm wanting the tangent of 15 degrees. Since he said use a half-angle identity, and I'm working with the tangent function, let me slide these back up here. We have a choice of which of these we might want to use. So I'm probably going to suggest let's use one of these just because it doesn't involve that square root sort of thing. Maybe it will be a little bit easier for us to simplify one of these two expressions. So it doesn't really matter which of these we want to use. I think I'm just going to use this middle one. So I'm going to write down here the identity so we can look at it. We have the tangent of a over 2 equals the sine of a divided by 1 plus the cosine of a. Now in my problem, a over 2 is 15 degrees, isn't it? So what would a be? If I multiply both sides by 2, a would be 30 degrees. Okay? So tangent of 15 degrees is going to be the sine of 30 degrees divided by 1 plus the cosine of 30 degrees. Notice what I have here. If I multiply by 2, I get this, or whatever I have here, if I divide by 2, I get this. That same relationship. Now let's simplify this. Since 30 degrees is one of our special angles, the sine of 30 degrees we know is 1/2 over 1 plus the cosine of 30 degrees is square root 3 over 2. Now I'm going to simplify this complex fraction by multiplying the numerator and denominator by 2. 2 times 1/2 is 1. 2 times 1 is 2. Plus 2 times this, the 2's cancel, and we get square root 3. Now we might want to rationalize this. So recall, if you've got two terms down here, you use the complex conjugate, 2 minus the square root of 3 to rationalize. We multiply numerator and denominator by that. So in the numerator, I have 2 minus the square root of 3. And here we get difference of squares, 4 minus 3. Remember, 2 times 2 is our 4. Outside, inside drops out. That's the reason we use conjugates. Minus the square root of 9, which is 3. Well, of course, 4 minus 3 is a 1. So this just simplifies to 2 minus the square root of 3. And we have that tangent of 15 degrees. The exact value, notice. use a half angle identity to find the exact value of the cosine of 67.5 degrees. Now, he said again to use a half angle identity. I'm working with the cosine function here. So the cosine of a over 2 was plus or minus the square root of 1 plus the cosine of a all divided by 2. So we're going to work with this formula. I have the cosine of 67.5 degrees here. Now, 67.5 degrees is in the first quadrant, isn't it? Since I'm in the first quadrant, I will choose the plus sign. So I'm going to write it down just to emphasize I've made that decision. Now over here we have 1 plus the cosine, and what needs to go here? Whatever is here, I do what? I multiply by 2 to get a, right? So let's take this 67.5 and multiply by 2. And I'm getting 135 degrees. Now 135 degrees, let's remember that 135 degrees. That's over here in second quadrant, isn't it? What's my reference angle? 45. So because we are in the second quadrant with 135 degrees, this cosine of 135 degrees is going to be negative. So I'm going to put my negative sign down. And the cosine will be the same as 45, which is square root 2 over 2. And then all of this is over 2. Now keep in mind, guys, this square root includes all of this stuff, doesn't it? Now what I'm going to do is work underneath this square root. I'm going to multiply the numerator and denominator of this fraction under there by 2. So 2 times 1 is 2, minus 2 times square root 2 over 2, the 2's cancel. I get square root 2. And notice down here, 2 times 2 is 4. Now, I can do the square root of 4, can't I? So I'm going to finally write this as the square root of 2 minus the square root of 2, all divided by 2, having taken the square root of that 4. Now, again, remember, if you're using this half angle identity, whatever's over here, you need to multiply by 2 to get what's over here. It's this angle that determines your sine. But then this angle, you have to pay attention to which quadrant you're in there to know what happens here. Okay? Use a half angle identity to find the exact value of sine pi over 12. Since I'm doing the sine function, let me write the half angle identity for sine. Sine a over 2 is plus or minus the square root of 1 minus, see I'm thinking sinus minus here, cosine A, all divided by 2. I'm working with the sine of pi over 12. Well again, let's think about pi over 12. What quadrant is pi over 12 in? It's in quadrant 1, isn't it? So that sine value is positive. Okay, now whatever's here, I do what to get what's here? I multiply by 2. So if I take pi over 12 and I multiply by 2, I'm going to get pi over 6. So 1 minus the cosine of pi over 6, all divided by 2. Okay, since I've chosen the plus sign in front of my square root, I don't need to keep writing that. Now the cosine of pi over 6, remember pi over 6 is like 30 degrees, so that's going to be square root 3 over 2. Notice the subtract stays a subtract because the cosine of pi over 6 is a positive value over 2. Now we'll multiply numerator and denominator down here by 2 to simplify that complex fraction under there. 2 times 1 is 2 minus our 2's cancel here, square root 3, all divided by 4. And then again, I can take the square root of that 4 down there, can't I? So square root 2 minus square root 3 is all divided by 2. And again, we have the exact value of the sine of pi over 12. Okay, I've got one more of these exact value problems I want us to look at here. We're to use a half angle identity to find the exact value of cosine 165 degrees. Again, he said to use a half angle identity. So the cosine, since that's the function we're working with here, cosine A over 2 is plus or minus the square root of 1 plus the cosine of A, all divided by 2. Okay, I have the cosine of 165 degrees here. Now, which quadrant is 165 degrees in? That's in the second quadrant, isn't it? And in the second quadrant, my cosine value is negative. So here, I want the negative square root so that my cosine value will be properly negative. Now here I've got 1 plus the cosine, and I need to do what? I need to multiply this 165 by 2 to get what goes over here. And I'm getting 330 degrees here. Okay. All right, well, that turned out nice because we know 330 degrees is over here in quadrant 4. And it has a, 30-degree reference. In quadrant 4, my cosine is positive, isn't it? So 1 plus the cosine of 30 degrees is square root 3 over 2. All of this is over 2. Now recall what my next step is. I want to simplify this complex fraction under here. So I'm going to multiply the numerator and denominator by 2. So I have minus the square root of 2 plus the square root of 3 all over 4. And then again, I can take the square root down here. So finally, minus the square root of 2 plus the square root of 3. All of this is divided by 2. Now, I hope you're getting really familiar with these half-angle identities now, and you're beginning to get the format of when do you multiply the angle by 2, when do you divide the angle by 2 to get the appropriate side of those identities. And I hope you're also beginning to get these identities memorized. Now, we have some other types of problems where we're given certain information and we're asked to find another quantity. Let's take a look at one of those. Here we are given the cosine of theta is negative 5/8, and also we're told that theta, notice here, is between pi over 2 and pi. And we're to find the sine of theta over 2. Well, let's see. If I want to find this, let's write down sine theta over 2 here. Our half-angled identity is going to say plus or minus square root sinus minus. So 1 minus the cosine of what? Well, if I take this and multiply by 2, I get theta, don't I? Over 2. Okay? So there's the identity that I want to use. Well, let's see. I'm going to start over here with 1 minus. Notice I'm given the cosine of theta. It's negative 5/8, so I have 1 minus a negative 5/8 here over 2. Now, that's real good, but what I've got to decide is, do I want the positive square root or the negative square root here? Now, notice theta over 2 determines that, not theta. Here, we're given theta. What I want you to see is with this inequality, if you multiply each part of this inequality by 1/2, 1/2 times pi over 2 is pi over 4, less than. 1/2 times theta is theta over 2, less than 1/2 times pi, I was trying to think in theta there, pi is pi over 2. So theta over 2 is between pi over 4 and pi over 2. That puts that in quadrant 1. If I'm in quadrant 1, I need the plus sign here. Okay? Now let's do a little work to simplify here. Of course, this is going to change to 1 plus 5/8. Now I need to simplify this complex fraction. Of course, you could change 1 to 8/8 and add these, but I'm going to do this similar to what we've been doing on these other problems. I'm going to multiply the numerator and denominator by 8. Do you see why I'm choosing 8? Because that's going to clear out this fraction right here, isn't it? 8 times 1 is 8 plus 8 times 5/8 is 5, and 2 times 8 down here is 16. Well, 8 plus 5 is 13, so the numerator is the square root of 13, but notice we can take the square root of the denominator and get 4. So our value of sine theta over 2 is the square root of 13 divided by 4. Given the sine of theta is negative 1/5, theta is between 180 degrees and 270 degrees, we're to find cosine theta over 2. Okay, well, cosine theta over 2 is plus or minus square root 1 plus the cosine of theta all divided by 2. Now notice this time I'm not given the cosine of theta. I'm given the sine of theta. But if I know the sine, I can calculate the cosine, can't I? I will do that in a second. But what I want to do is let's go ahead and decide, do we want positive or negative square root? Remember we need the quadrant for theta over 2, not theta. Here we're given theta. What happens if I take each part of this inequality and divide by 2? Then I have 90 degrees is less than theta over 2 is less than 135 degrees, right? Okay, well, what quadrant is theta over 2 in then if it's between 90 and 135? That's quadrant 2, isn't it? So if theta over 2 is in quadrant 2, then I need minus, because the cosine is negative in quadrant 2. So we've chosen the appropriate sign. Now here I've got 1 plus. Okay, let's figure out this cosine of theta. Well, let's go back. Where was theta? Theta was between 180 and 270. So that puts that in quadrant 3, doesn't it? And if the sine is negative 1/5, then y is negative 1 and r is 5. So let's see, 25 minus 1 is 24. The square root of 24, 4 times 6, is 2 square root 6. So remember, this is negative, negative 2 square root 6 here. So the cosine is going to be x, negative 2 square root 6 over r, which is 5. And then all of this is divided by 2. Now what will it take to clear out my fraction up here? It'll take multiplying by 5, won't it? So we're going to multiply the numerator by 5 and the denominator by 5. So let's not leave that minus in front of our square root. Okay, well, 5 times 1 is 5. Notice plus here, but that's a negative, so that's going to be a minus. Our 5's cancel. 2 square root 6. And 2 times 5 is 10. Now here, notice, we did not get a perfect square down here, did we? Now there's a couple of things you can do then. You could rewrite this as square root 5 minus 2 square root 6 over square root 10 and rationalize. Or I'm going to do it this way. What would I need to multiply times 10 down here to have a perfect square? It'd be a 10, wouldn't it? 10 times 10 would be 100, and then I could take the square root. Well, if I do the denominator by 10, I can do the numerator by 10, can't I? Okay, so let's do that. So I've got the square root of 50 minus 20 square root 6 over 100. Now I can split this out. Minus the square root. 50 minus 20 square root 6 will all be divided by 10. Now, please remember that I can't simplify this 50 thing under the square root because of that subtract right there. So there's nothing I can do to simplify this numerator part. Okay? Sometimes I do this. It's maybe a little bit easier than rationalizing later. If you don't have a perfect square, think about what could I multiply by to make it a perfect square, whatever that is. Just do the numerator and denominator both by that quantity, and then you'll be able to take the square root down there and not have to rationalize. Well, I've got another problem that I want us to look at. Given the cosine of 2 theta is 1/2, and theta terminates in quadrant 2, Find the cosine of theta. Now you might be thinking that sounds like a problem that we had in our last lesson when we did double angle identities. And you're right, we could do it that way. What I want to do is to show you in this problem two different ways of working this particular problem. I want to put down first our half angle identity that we've been working with. Cosine theta over 2 is plus or minus the square root of 1 plus the cosine of theta all divided by 2. And we have been concentrating in these particular identities with talking about the relationship that exists. Whatever you have here, if you multiply by 2, you get this. Or whatever you have here, if you divide by 2, you get this. I'm going to rewrite this identity this way. The cosine of theta is plus or minus the square root of 1 plus cosine 2 theta divided by 2. Now look, what I have here, if I multiply by 2, I get this, just like here. Whatever I have here, if I divide by 2, I get this, just like this one. This is an alternate form of this identity, and we can use it either way. Now actually, for you students who are going on to calculus, we tend to use this half angle identity in this form rather than in this one a lot. So let's use this thing right here. Notice we're trying to find cosine theta. So let's see, cosine theta equals. We need to decide on our plus or minus. Well, notice right here, he told me what? Theta terminates in quadrant 2. So this theta right here is in quadrant 2, so its cosine value will be negative, won't it? Okay. Now, we've got square root 1 plus, notice here's the cosine of 2 theta. Well, he gave me cosine 2 theta is 1/2. And this is all divided by 2. Notice if I multiply numerator and denominator by 2, I get minus the square root of 2 plus 1 over 4, which is minus the square root of 3 all divided by 2 if I take the square root of that 4. Do you see how we got down to this answer, minus the square root of 3 over 2? And we got there using the half angle identity. Now, I want to, just as a good review here, let's go back and think about cosine 2 theta, and remember the identity 2 cosine squared theta minus 1. Cosine of 2 theta is 1/2 equals 2 cosine squared theta minus 1. If we add 1 to 1/2, we get 3/2 is 2 cosine squared theta. If we divide by 2 or multiply by 1/2, whichever way you want to think about that, 3/4 is cosine squared theta. And then to solve, we'll need to take the square root, right? Well, which one? Well, theta terminates in quadrant 2, so we want the negative square root. And when we do that negative square root, notice we get negative square root 3 over 2. So would it be correct to do the problem this way? Yes, it would. Is it correct to do the problem this way? Yes, it is. So I wanted you to see that there are a lot of times problems where you can do these more than one way and be absolutely correct. The nice thing is, if you have these identities up in your mind, then that does give you a variety of choices, and sometimes one choice might be a little bit easier than another. I had fewer steps using the half angle identity than I did solving that equation when I used the double angle identity, didn't I? All right, we're going to move from working problems to verifying some identities now. So let's remember that when we're verifying identities, we pick one side of the identity to work with, and we try to use either algebra things that are true or identities that we know are true to rewrite these quantities. Now, since we've had these half angle identities, we maybe can use those. Don't forget, we also have double angle identities. We have identities for the sum and difference of angles, and we have our basic fundamental identities. All of those we can choose from, as well as just algebra, to see about verifying these identities. Let's take a look. I'm to verify the identity 1 minus tangent squared theta over 2 equals 2 cosine theta over 1 plus cosine theta. Now the thing that draws my attention in this one is this theta over 2 thing right here. okay? Now, we haven't done a lot with this tangent of theta over 2, so let me slide this thing up here. And let's look, I've got 3 choices here for tangent theta over 2, okay? Notice in my problem, I'm wanting to do what? I'm wanting to square that, okay? Well, if I square this first one, what would happen? Let's talk about that. Well, if it's positive or negative, either one, it would not matter, because if I square, I'd get a positive. But if I squared both sides here, I would remove the radical on this side, wouldn't I? Now here, if I square both sides, I would get a sine squared here, and I would have a 1 plus cosine quantity squared. And here I would have a 1 minus cosine quantity squared over sine squared. So with those things in mind, let's take a look at what we're wanting to show here. I'm wanting 2 cosine theta over 1 plus cosine theta. Well, I have a feeling any of these identities would work, but I'm sort of thinking ahead. If I square and remove this radical on this identity, I'm going to have 1 plus cosine right down there where I want it. So let's start with this left-hand side. 1 minus tangent squared theta over 2 equals. Let's just bring down this 1 and our subtract sign. And again, let me slide this up here. We're using this identity where instead of a we have theta. So these will be thetas. Since I'm squaring, then this will become positive and this square root will go away. So I will have 1 minus cosine theta divided by 1 plus cosine theta. Okay? So we've used this first identity. Now, I think what I'm going to do is rewrite this 1 as 1 plus cosine theta over 1 plus cosine theta, subtract 1 minus cosine theta over 1 plus cosine theta. I'm doing that so I can get a single fraction like I have up here. So I know my denominator down here is 1 plus cosine theta, and that's exactly what I want. Now let's see what happens up here. I have 1 plus cosine theta minus the quantity 1 minus cosine theta up here in the numerator. When I distribute that negative, I'm going to get 1 plus cosine theta here minus 1, notice plus cosine theta. All of this is over 1 plus cosine theta. So when I simplify 1, subtract 1, those add to 0. Cosine theta plus cosine theta is 2 cosine theta, and that's over 1 plus cosine theta. And when you compare, we have verified that the two sides are equal. Now, as I mentioned, probably I could have verified using either of the other identities for tangent theta over 2. It may have just looked a little different. I don't know if it had been harder or not. But in this case, because I was squaring, I thought that first one looked rather nice because it had what I wanted right here. Okay? Verify the identity. Sine 2x over 2 sine x equals cosine squared x over 2 minus sine squared x over 2. Well, notice here I've got a double angle and here I've got half angles. So I think what I'm going to do on this problem is let's take a look at these half angle identity things for sine and cosine again. Okay? Here's sine and here's cosine. They both involve square roots, don't they? Notice in my problem I'm squaring these things. So if I square this, I'll remove the square root. If I square this one, remove the square root. And again, whether it's positive or negative won't matter because when you square either of those, you get a positive. So I think what I'm going to do is to start with this right-hand side, cosine squared x over 2, subtract sine squared x over 2, and let's just see what happens. Now, let me slide this back up here a little bit. It's kind of catty corner, but maybe you can see it. We've got an x instead of an a, and we're squaring both sides. So on the cosine, we're going to get 1 plus cosine, in our case x, all over 2. So 1 plus cosine x all divided by 2. Now we're subtracting, aren't we? And now we're going to square this sine of, in our case, x over 2. So we'll remove the radical when we square. 1 minus cosine x divided by 2. Okay, we have a common denominator here. So 1 plus cosine x, subtract the quantity, 1 minus cosine x, will all be divided by 2. Remove our parentheses, 1 plus cosine x minus 1 plus cosine x is all divided by 2. 1 minus 1 is 0. Cosine x plus cosine x is 2 cosine x. Well, 2 cosine x over 2, I can divide by 2 and get cosine x, right? Okay? Now, that doesn't look like this, does it? But that's real simple. So I think what I'm going to do next is let's take this other side, sine 2x over 2 sine x, and let's work with it a while. So do you recall your double angle identity for sine 2x? Sine 2x would be 2 sine x cosine x. That's over 2 sine x. Notice we can divide by the 2's and the sine x, and that simplifies to cosine x. So what have we done? We've shown the right-hand side is equal cosine x. The left-hand side is also equal cosine x. So since the two are equal to a common third side, they're equal to each other, and we have verified this identity. Now this completes the lesson on the half-angle identities. I do encourage you, in particular students who are going on to calculus, spend some time with these half-angle identities and make sure you understand them. Work on that relationship between the two sides of the equation. What goes on one side, what goes on the other. And spend some time memorizing these identities.